familiar with functions from algebra. I'm sure you talked about functions, right? Am I right? Yeah. So what we're talking about with functions is making things fair. So one job, one pay. That's the way I like to think of it. It isn't fair if one person gets $10 an hour and another person gets $16 an hour for doing the same work, right? Now, there are jobs, like teaching, for example, where we kind of do the same job, but you can get extra credentials and get extra pay. Or if you work longer and you have more experience and you get extra pay, you can be doing the same job but get extra pay because your credentials. We're not talking about that. We're just kind of just saying bare bones, one job, one pay. I like the sort of pop machine thing. If you one day you put $1.50 and you get one, you're like, I got 3 once in the math office. I was so excited. Got 3, but again, the machine isn't working. So what do you need to know? You need to know really one thing on this slide, and that is that whenever you see f of x, cue in your brain, that's the same as y. Okay? So what we're saying is for any x, this is called the element of. For every x, element of the real numbers or whatever you want to call it, f of x, put this, have you ever seen function machines? Does that sound familiar? Have you ever seen these? Some teachers do it, some teachers don't. So you put in like a 5 into the machine and you get a 7. That's really what the function is. Now what if you put in a 5 and the next moment you get an 11? What are we saying about that machine? It's not a function. It doesn't work anymore. So 1x, 1y. And then f of x is a rule in terms of y. That's an f of x rule or equation. This is mapping x's to y's. It's a little different than a relation. Anything goes in a relation. But functions are a special kind of relation. Every x goes to 1y. Now there's 3 ways that you can do it, that you can analyze this function idea. One is the idea of listing coordinates. So if we list coordinates, here's what happens. You'll have 1, 3, 2, 3, 1, 5, 6, 4. Think of what I said about every x having 1y. Did I make that happen or not with this list? No. One moment we have x going to 5, and another moment x is going to 3. So we would say not a function. That's easy, right? If you graphed it, what it would look like is x going to 3 one moment and 5 the next. And so we said it's not a function. What do you notice about the placement of these two? They're what to each other? What do we say geometrically? They are what? Horizontal or vertical? Vertical, right? So we have something we call the vertical line test. You remember that? So you have, something like this. Will this pass the vertical line test? No. But we're saying the same thing. Every x should have 1y, so this would be not a function. One job, one pay, one job, 3 pays for this one, so it's not a function. You like the vertical line test, don't you? It's a real quick way to do it. And then the third way is the rule way, or the function way. All that we're saying is if we were to solve this, y squared plus 4, y squared equal to x minus 4, solving for y, how many rules would you get? Well, I would get the square root of x minus 4. What other rule would I get? The opposite of x minus 4. these are the answers for this. This has two rules, so it's not a function. You good with that? It's easy. So the three things are, remember, every x has one y. If you have a coordinate list and you look for the x's, there should only be one y. If there's two, it's not a function. If you draw the graph and you draw a vertical line and it hits more than once, then you know, same thing. X has more than one y, so therefore it's not a function. Same thing here. If you have one x, you can have more than one y. So it doesn't work. This one seems a little harder, but it's just dealing with odd power of, or an even power of y. If it's an odd power, it's fine. And then we can, like we said before, we can make this a little machine. We have a machine that says the f of x machine is 3 minus x squared. So we can put in a 4 into that machine, and you'll get f of 4. Would you write that down? What are we looking for? An x or a y now? Y, because you put the x in, you're going to get f of x, which is the same as y. So 3 minus 4 squared is just going to be 3 minus 16, which is negative 13. That's f of 4, or we call it y. So this is negative 13. Now this question's interesting. We're saying we already know y. There's my y. We're trying to find x. So what you would do with this is you would say y equals 3 minus x squared. Now what are you going to do? Yeah, solve for x. You got it. So x squared will be equal to 3 minus 2. X squared will be equal to 1. X will be equal to positive 1 or negative 1. We don't have to put numbers in. We could put letters in, variables in, like c. So this will be 3 minus c squared. Or if you wanted to, you could put in something more complicated, 3 minus c plus 1 squared, but it's still putting this into my function machine. You're putting in a c plus 1, and you get what comes out, 3 minus c plus 1 squared. This one, I'll let you think about. We're going to do tomorrow. I'll let you toy with that. See if you can figure out. This is one of the cornerstones of calculus that you're going to see. For homework, you're going to analyze these problems and find whether they're functions or not. And then I'm going to ask you to do one other thing. Would you list the domain and the range? So like this one, let's just do it. What's the domain? What are the x values of this beast? Just list them off for me. Negative 3, 1, 2, 4, negative 5. We don't need to list the 4 again, and 6. Those are the x's. And then the range are the y's. So these are the x's, these are the y's. So here we're going to get 0, 6, negative 3, 2, 6, negative 9. We don't need 2 again. Is that good? Okay with that? I'll let you decide, is this a function or not? Now for these, you might have to use something more than just, you can't list all of them because they're infinite, but I'll let you figure that out. And then this one with the drawings, you're going to do the same thing. By the way, is 15 a function or not? Here's the shape. Is that going to be a function? Does it pass the vertical line test? It does. Flying colors. So we would say, yes, a function. So for the domain, we try to describe what x values are going to work. Well, this one kind of goes off into infinity, negative infinity, and positive infinity. That's the domain of that. What do you think? Let's do it this way. Let's do it this way. Put an interval, negative infinity to infinity. That's simple. What's the range going to be? Turn to your neighbor. Tell them what the range of this is. What y values are possible? I'll give you a hint. This is going to infinity. One? You got it. So you're going to do vertical line test, check to see that it's a function, or if it's not, we'll call it a relation, and then you'll give me the domain and range. Some of these will be very interesting. And then this last part,